A synchrotron light source is a broad research facility that has applications in physics, chemistry, material science, pharmaceutical industry, archaeology, cultural heritage. Electrons are accelerated. They are injected into the storage ring where the electron reaches its full energy of 2.5 giga-electron volt. Light is emitted in conical form. This light is then guided in designated beamlines where scientists put their samples in order to conduct their experiments using the high-intensity photon beam that is coming through these beamlines.
From the scientific point of view, it was decided that a synchrotron radiation laboratory was a good idea because of its interdisciplinary nature. We could attract science from several fields ranging from physics to biology to medicine to engineering.
These kind of machines are very much oversubscribed, so the users and the university in the Middle East are forced to go to the European facilities or to the American facilities, while now with Sesame coming into operation, they have a facility which they can use locally, so they don't need to travel. So there was a need to provide a local machine to cater for the need of the users locally.
Sesame is located in Jordan, in Al-Lan, northwest of the capital Amman. Sesame stands for Synchrotron Light for Experimental Science and Applications in the Middle East.
With the help of the UNESCO and with the help of specifically the Jordanian government, Jordan was selected to be the host in the country because Jordan is at that time the only country that have diplomatic channels with all the other member states.
Sesame enjoyed a lot of support from the international synchrotron scientific community who supervised and worked with the scientists from the region to redesign and build the machine.
The staff at Sesame has the need of being able to cope with different and a broader spectrum of technical problem than what's normally happening in other light sources. So they are engineering and physicists which have been trained in the past years, and they have certainly benefited from the help of many light sources in Europe. There's a number of programs just for training where we send the people to those facilities in order for them to learn or to compare what they do at Sesame with what we do in the European facilities.
I had an opportunity to visit Soleil, another facility in France. They are already running, so I had the opportunity to have some interaction with people who are already doing this kind of job at similar facilities to this one.
So far, we have had 2 user groups coming from the region. One group came from Cyprus and the other group came from Jordan. In particular, they studied bones and teeth coming from excavations in Cyprus. With synchrotron radiation, they were able to identify a type of diet they were following on the contamination which occurred in the excavation site afterwards. These type of experiments cannot be done without synchrotron radiation, this particular type.
Each year, we are allowing the platform for all the scientists to be engaged with the Sesame staff and to get to visit Sesame and to see the beam lines and the topics to be considered for future research. And this is the main umbrella for us to engage the scientists from all over the world to be with us in Sesame.
Sesame selects the experimental proposal on a competitive manner. So we collect proposals, there is a bid, and there is a panel, international panel, which review the proposals. If the proposal is good, there is no question of nationality. We can accept proposals from outside the Middle East as well as from the member countries.
I came to Sesame because Sesame gives the opportunity to help and also develop research in the region here. I have the duties to support users from different places in the region and also carry my own research where I looked at sediments and toxic elements in soils.
Sesame is fulfilling my personal view about not only science but also our human nature. We're using science as a neutral language that we can produce something useful for our societies, as well as proceeding with our human nature, accepting each other and moving together towards just one goal,
As we are operating now 2 beam lines, the X-ray fluorescence and the infrared beam line, we are shortly going to finish the construction of a material science beam line. We are working also on a macromolecular crystallography beam line, and we have got a generous grant from EU of around 7 million euros to construct a tomography beam line. And also we are in negotiations with the Helmholtz Society from Germany, who will generously donate funds to construct additional 7th beam line. Sesame will have a great positive impact on promoting the culture of advanced scientific research in the region, to promote a culture of scientific excellence, and to allow scientists within the region to really work with their peers from other synchrotron facilities globally. It will definitely raise the level of scientific research within the region to a totally new level of excellence. Science that can be read and published in the most prestigious scientific journals around the globe.